Hello everyone, thank you for joining me in today's class. In my previous video, I explained balancing of chemical equation using the physical observation or the trial and error method. In that video, I explained that the trial and error method can be time consuming, meaning it can waste your time. And for freshers who are just learning chemistry, it can be very frustrating, especially when you are presented with a long equation or a complex equation. In today's video, I present to you an alternative method of balancing chemical equation without tears. This approach is simple and easy to comprehend. Let's get started. The question on this board is GCSE chemistry organized by WAEC, an examination body in England affiliated to Educas. Now, the summary of the whole question written here is that we are to balance this equation KNO3, that is potassium nitrate, aluminum hydroxide, producing aluminum nitrate and potassium hydroxide. All right? So, let me give you few seconds to copy down the question. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, thank you. So, the first step in solving this problem is written here. Step 1, identify each element present. So, we come back to the equation and write out all the elements present by using their symbols. Of course, the first one here is K, which is potassium. The next element is nitrogen, represented by capital letter N. The next element is oxygen, represented by O. The next element is aluminium, represented by what? Al. We have written for oxygen. And the last element here is hydrogen. That is the first step. Step 2. Put letters A, B, C as coefficient beside the reactant and product. The equation you have on the left-hand side is actually your reactant, and what you have immediately after this arrow, which is the right-hand side, is what? The product. So we have to put letters beside all of them. So we begin. A, B, C, and D. Step 2, done. Step 3, multiply the letters, these letters, all right, and the subscript number on the left-hand side and right-hand side. So, the subscript number, like I said, is the number that is written at the base here. In the case of potassium, no number is written here, so we interpret the number here to be 1. Potassium, just 1. So we use this 1 here to multiply the A. So 1 times A, that gives us what? A. You write it in front of potassium. You move on to the next element. How many atoms of hydrogen do you have here? This is 1. Meaning the subscript number for nitrogen is 1. Use it to multiply this coefficient. 1 times A, that gives what? A. You move on to oxygen. The subscript number of oxygen, which is the base number, is 3. Use this 3 to multiply A. That is 3 times A. That is 3A. You move on to aluminium. Aluminium has a subscript number or a base number of 1. Invisible 1. Use it to multiply this B. 1 times B. That gives what? B. You move on to oxygen. Okay? Oxygen is here. Remember, we have done one oxygen before. This oxygen that is here is captured inside the bracket. This 3 that is outside the bracket is going to affect both the oxygen and the hydrogen. So the oxygen atom here is 3. So 3 oxygen, that is 3 times this B, that gives 3B, right? But because there is a plus sign here, so we go back to oxygen and put plus 3 times B, that is 3B. Then we do again for hydrogen. Hydrogen is inside the bracket, like I said. So this 3 that is outside it means everything inside the bracket here is affected by this 3. So 3 hydrogen, that is 3 times B for hydrogen is going to be what? 3B. Now, this arrow should be interpreted as an equality sign. So we write is equal to here, is equal to, is equal to, is equal to, and is equal to. We do the same thing for this side. The atoms of aluminium here is 1. That is the base number or the subscript number is 1. Use it to multiply this C. 1 times C gives what? C. So for aluminium on the product side, C. Then, like I said, everything inside this bracket, the NO3 inside this bracket is affected by the 3 that is written outside it. So, meaning the nitrogen is 3. So, 3 nitrogen times C. So, 3 times C for nitrogen, that gives 3C. Now, the oxygen inside this bracket has 3 as its base. There is another 3 outside. The meaning of this bracket is multiplication. So this 3 outside multiplied by 3 oxygen, that is 3 times 3, 9. 9 oxygen multiplied by this C, that is 9 times C. That gives what? 9C. So we locate oxygen and we put 9C here. We come back to this side, there is a positive sign here. Then we move on to potassium. The base number or the subscript number for potassium is 1. 1 times D, that is D. So we locate potassium and we put D here. 1 times D is D. For oxygen, the subscript number or the base number is just 1. 1 times D, that is D. So we locate oxygen. Because there is a plus sign here, before we transit to this potassium hydroxide, that becomes plus, okay, 1D for oxygen, which is the same thing as D. And for hydrogen, which is 1 atom here, use it to multiply this D. 1 times D, that is D. So we locate hydrogen. 1 times D is D. And that is equal to what? D. So, step 3 done and step 4 done. Okay? Because step 4 says we should equate the left-hand side of the equation to the right-hand side of the equation, which I have actually done. The last step says we should find the values of each letter. Okay? But before that last step, step 5 says always make letter A to be equal to 1. Anywhere you see A in this equation, just equate it to 1. So, therefore, for this first one, if A is taken to be 1, whether today or next year, anytime, A should be treated as what? 1. So, this equation becomes 1 is equal to D, which means D is equal to what? 1. So, we have gotten our D to be equal to what? 1. Alright? Now, to avoid confusion, I think I need to extend this part very quickly. So, if A is equal to 1, then D is equal to 1. So, we have done for D. Then, we come back here. For nitrogen, if A is equal to 1, what do we have? Then 1 is equal to 3C. Therefore, C is equal to what? 1 all over 3. Meaning we are dividing both sides of the equation by what? By 3. So we've gotten our C. We come back for oxygen, right? For oxygen, so anywhere we see A, we put it to be 1. That is 3 into bracket 1 plus 3 into bracket. What is our B? We don't know. We don't know letter B is equal to 9 into bracket. What is C? C has been gotten as 1 over what? Over 3 plus what is our letter D? We calculated that early to be what? 1. So if we expand the bracket, 3 times 1 gives 3 plus 3 times B gives 3B is equal to 9 times 1 all over 3. That is 9 times 1 all over 3. Simple mathematics, 3A1, 3 goes in 9 3 times. So 3 times 1 gives 3 all over 1. So 3 over 1 gives 3 plus 1. So we have 3 plus 3b is equal to 3 over 1 is 3 plus 1. That gives 4, right? So 3 plus 3b equals 4. Collect the like times, meaning this 3 doesn't look like 3b. So we transfer it to the other side. 3b is equal to 4 minus 3, which is equal to what? 1, right? So 3b equals 1. To find b now, we divide both sides by what? By this 3. So b is equal to 1 all over what? All over 3. So our b is 1 all over 3. So we have gotten our a as 1, our b as 1 over 3, our c as 1 over 3, and our d as 1. So we go back to the equation, right? And we substitute. So instead of a here, I will put what? 1. Instead of b, I will put what? 1 all over 3. Instead of c, I will put 1 all over 3. And instead of d, I will replace it with what? Ordinary what? 1. Now, here is the challenge. As you can see, there is a fraction in this equation after we have balanced it up. So to eliminate this fraction, you have to multiply everything inside this equation by the denominator 3. So if you multiply every single thing by denominator 3, because that is the only way to cancel out this fraction. So this one becomes 1 times 3. This one becomes 1 over 3 times 3. This one becomes 1 over 3 times 3. And the last one becomes 1 times 3. So 1 times 3 gives what? 3. So I will erase this and put 3. 1 over 3 times 3 gives you what? Ordinary 1. So I erase this and put 1. 1 over 3 times 3 gives ordinary 1. So I erase this and put 1. Then 1 times 3 produces what? 3. So let's verify if this equation is what? Balanced. How many atoms of potassium do you have on the left hand side? 3. How many atoms do you have on the right hand side? 3. 3 potassium. How many nitrogen on the left hand side? This is 3 nitrogen. How many do you have on the right hand side? Remember, this 3 outside the bracket, we have filled this nitrogen inside the bracket. Nitrogen is also what? 3. How many oxygen do we have on the left hand side? 3 times 3, 9. There is another oxygen here which is being affected by this 3. So you add it. So 9 plus oxygen 3. 9 plus 3 gives what? 12. You come back here. This oxygen is 3. There is 3 outside. 3 times 3, 9. 9 oxygen. Plus this 3 that is in front of KOA, because this number here affects every single element here. So 9 plus 3 gives 12. Oxygen is equally balanced. Let's go back to aluminium. Aluminium is how many here? 1. How many can you see here? Just 1 aluminium. Then hydrogen is how many here? 3, right? H 3. How many hydrogen do you have on the right hand side? This 3 affects the hydrogen. 3. As you can see, this equation is already balanced. Okay, if you have enjoyed this video, kindly subscribe to our various social media platforms. Drop your comment on this video, like this video, share this video, okay, and follow us. Should you have any question for me, please feel free to reach out to me. As a parent, if you are interested in enrolling your ward on the online academy platform, all right, organized by Lyceum Academy, please do well to reach out to us on the WhatsApp number being shown on your screen. Until some other time when I will be coming your way, thank you so much for watching. Cheers.